What is up, fellow mathematicians? I know this video is going out a little late where I am. It's a dark, rainy night out there. You can see nothing out the good old window, but I'm sure that for some of you Math Made Easy fans in Asia, Australia, Polynesia, it's just on time. So let's get into this. So this title looks kind of clickbaity, I know, but it is probably the coolest thing I've found out today. Because, some of these really dark, rainy nights, it's just a time for a good old deep think. And I was just thinking about my cubic numbers. Actually, I was on my way back from golf practice today. And I played very poorly. No surprise there. And I was thinking about cubic numbers because that's what I do when I'm sad. And I found this really cool thing that I know you guys will love. So let's get straight into it. So let's list our cubic numbers to start off. So 1, 8, 27, 64, 125. And we'll only go up to here. Of course, they go on 216, 343, 512, 729. What's the next one? 1,000, of course, and then 1331, 1728, and I can stop flexing my knowledge of cubic numbers. So when I was thinking is, I'm thinking about the differences between these. So we're actually going to put 0 at the front of this list as 0 cubed. So this is 1, this is 7, this jump, 19, 37, and 61. Let's make a hexagon now. We have one little hexagon. We have... I should not even try to do this. These are more like trapezoids, but it still does the same thing. So in this case, we have 7 regions making up our hexagon. If we were to go out further, we would have 19 regions making up our hexagon. And you should recognize this sequence, if you're a sequence person, as the hexagonal numbers. So notice, I'll just show those of you who don't believe me here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus the 7 in there is 19. And in fact, that's the same for 37, because if you think about this, there's just 1 here, and then 1 on each side, 2 on each side, and then 37 will be 3 on each side. So there will be 18 total. And that's going to be how it's going to work. So that in itself, I think, is pretty cool. And that is it's just so magical, I think. Because I didn't know hexagons and cubes had this relationship. These are the hexagonal numbers. So great, I made a geometric observation using numbers and the sequence that I know of. But can't you find 2 consecutive cubes that the difference is not a hexagonal number? I'm going to prove this for you guys. If you guys want me to do more proofs, let me know in the comments down below. Also, like this video, subscribe, turn on the notification bell, all that stuff, so that you always know when I do epic stuff like this. So, I was thinking about hexagonal numbers, and I was noticing, hey, each side represents like a triangle, right? So there's 1, then there's 2, and then there's going to be 3 on this side, and then 4, 5, 6 in each layer. So it's just going to be the triangular numbers. Let's take the triangular sequence. So 1, 3, 6, 10. And most people who have gone through a basic amount of maths training and have indulged themselves in sequences are familiar with the idea that this is just going to be n times n plus 1 over 2. And this is just the nth term in the sequence. So first term is going to be 1 times 2 over 2. So 1. Second term is going to be 2 times 3 over 2. 2 cancels 3. Sixth term, you can try that. It'll work. That's how you find the nth triangular numbers. Just plug it into that formula. But I notice I have 6 of these little triangular regions in my little hexagon. So I'm going to, in fact, multiply this by 6. So 6 and the 2 can kind of cancel to give me a 3. Okay? So, and you can either write it as 3n times n plus 1, or you can write it, I kind of like to write it as 3 times n squared plus n. And I will show you why in a minute. And then we just have to account for the fact that there is this central piece that our triangle numbers might not be accounting for. So we're going to add an extra 1 to that. So now we've developed this formula. I do not know if people have done this before. I'm sure somebody has, but literally this was an aha moment for me. I did not observe this relationship before. So it's 3 times n squared plus n plus 1. So let's try that. So nth triangular number. So let's try third triangular number. So 3 squared. Wait a second. Is this incorrect? No, that should be correct. I think that 1 in this case will function as the 0th triangular number, if that makes a difference, because it's kind of, the hexagonal number. So here we have, I was thinking about that because I'm like, I know I tested this and it was correct. So 1 is going to be our 0th. This is going to be our first. It's going to be our second. So 2 squared plus 2 is 6 times 3 plus 1, 19. 3 squared, 9 plus 3, 12, times 3 plus 1 is going to be 37. So how can I modify? Actually, we're not going to worry about the modification of the formula because this formula is actually going to be okay. It seems weird to have 1 be the 0th number. It's going to be the first number, but again, it will all work out later. So let's write out our cube. So we have, if we take a plus b and cube it, we cube this, we're going to have a cubed plus 3a squared b plus 3ab squared plus b cubed. And I have videos on how to cube binomials. I think I did that quite a long time ago, I think, but check that out, please. On my channel, you'll find it. And let's expand this out. 3n squared plus 3n plus 1. 3, 3, 3, 3. No coefficient, so 1 and 1. The only thing we're missing is this a cubed term. And, of course, b is functioning as 1 here, we can see, because b cubed is 1. And it also would make sense with these other terms, but we're looking at the difference between two cubes. So say we have 4 cubed and 5 cubed. We're just looking at the difference between them. So, in fact, we're going to subtract this whole thing. We're going to subtract the 4 cubed, which is the a cubed, and we get this, our hexagonal number. So, in fact, we were able to write the sequence in a way that we have cube number, cube plus that equals next cube. And this is basic maths, but I just think it's kind of cool that that connection is made with the hexagonal numbers. Just shows that things in math are interrelated. Everything is interrelated. I'm not sure that there was anything in math that really has nothing to do with anything else. Because math is all made for a purpose. Math is made to explain things. And when things are not explainable, there is no purpose for math. So said math does not really exist. At least, or exist in a meaningful, way. In an obvious way. So, yeah, tell me if you want me to do more things of this sort. I love doing this video, and when I proved this to my dad just to make sure, it wasn't just me thinking, and I love this kind of thing. So please like this video. I already went through this. Yeah, just comment your ideas. I need some ideas. What are you doing in your math classes right now if you're still in school? I know that my school is going to wrap up after next week. We're going to have no more academic school. We're going to do extracurricular studies. But yeah, have a nice day. Math made easy. Signing off.